Alrighty, 8.6, solving logarithmic and exponential equations. Okay, so the first one. Okay, we got 2 to the 4x equals 32 to the x minus 1. Okay, when we see this one, I see two exponents on both sides of the equation. So what we need to do in this case is we need to get the bases to be the same. Okay, because if I rewrote, it's going to be something real funky. So in these cases, when you got an exponent on both sides, get the bases to be the same. Okay, we got 32 and 2 as our base. Okay, I can write 32 with a base of 2. Okay, and that's going to be 2 to the 5th. And we're taking that to the x minus 1 power. Okay, so again, that's a power to a power, so we're going to multiply 5 times x minus 1. Now, remember, you're doing 5 times the quantity x minus 1, so 5 times x, 5 times negative 1. Common mistake I'll see there is 5x minus 1. Got to multiply it by that whole quantity. Now that we have the bases the same, then I can set my exponents equal to each other. Okay, now we got a simple linear equation that we can solve for x. We get negative x is equal to negative 5, or x is equal to 5. Okay, now always check your answers. Okay, if I check, that's going to say 2 to the 4 times 5, so 2 to the 20th. 32 to the 5 minus 1, which is to the 4th. Okay, there you can use your calculator and make sure that it is correct, which it will be. All right, so that's where we have an exponent on both sides. Now, where we get an exponent on one side equals a whole number. Okay, this is a case where we want to rewrite. Okay, so if I rewrite this, so remember, logs are the inverse operation of exponents. So when we rewrite, we're going to a log base 4 of 15 is equal to the exponent. Just by rewriting, we get x isolated. Okay, so we need to evaluate that log base 4 of 15. Now, there's two ways to approach this. You can use your change of base. Okay, so log of the argument over log of the base. Okay, by doing that, you are able to just use the log button on your calculator. Okay, so in this case, log of 15. Now remember, make sure to get outside of that parentheses because your argument is 15 divided by that log of 4. And we'll get x is equal to that 1.95. We'll go to the hundreds. Now, the other option you have, if you go into the math button, okay, you're going to see log base. Okay, so this is the operation we use on the calculator that allows us to change that base to 4, argument of 15, and we'll get the same exact thing. Okay, now on the test, probably the change of base is going to be the quickest, so you don't have to memorize. Go into math, log base. Okay, change of base formula, log of the argument over log of the base. All right, so that is how we approach when we have an exponent on one side equals a whole number. Now, here now we got an exponent plus a value equals a whole number. Okay, whenever you're solving for these exponential functions like this, you need to get the exponent by itself. So in this case, we have to subtract the 3 over, and we'll get to 5 to the x plus 2 is equal to 22. Have our exponent by itself. It's just like that last one. We got an exponent equals a whole number. Here is where we will rewrite. Log base 5 of 22 is equal to x plus 2. Now, to isolate x, we're going to have to subtract 2. But now, common mistake, people will subtract that 2 from the 22. You need to remember that is part of the argument. 22 isn't the number. Log base 5 of 22, that is the number. Okay, so we're subtracting 2 from that whole thing. So, do not subtract it from the argument. You're subtracting 2 from that log. Now when I go to plug that in, okay, again, I like to use that change of base formula, so I'm just going to do log of 22 divided by log of 5. And we subtract 2 from that. So log of 22, again, make sure to get out of that parentheses, divided by log of 5. And then we're subtracting 2 from that value. So we get x is equal to negative 0.08. Okay, now on these ones, what it comes down to, you know, plugging it in, negative 0.08. You're taking 5 to some power close to 2, okay, not quite 2, so it's going to be something less than 25. It's going to be actually 22 plus that 3. And again, we got a rounded answer here, so plugging that in isn't going to give you the exact answer. But we're in the right ballpark, so we should be good there. All right, now, when we get an equation where we have log base 4 something equals log base 4 something, the bases are the same. Now, if the left side equals the right side and it's both log 4, that tells me that these arguments need to be the same as well. Okay, so to do the actual inverse operations, okay, we would do what's called exponentiating. Okay, log base 4, okay, you're going to take 4 to the power of that side. And what that does, it just gets rid of the logs. Okay, so the big thing it comes down to, you see log base 4 on both sides of the equation, the arguments must equal each other as well. So what we're going to do, x plus 3 equals that 8x plus 17. And just solving for that, subtracting x from both sides, subtracting 17 from both sides, you're going to get to negative 14 is equal to 7x. Finally, dividing by that 7, you get x is equal to negative 2. Okay, now, check your answers. Negative 2 plus 3, that's equal to 1. 8 times negative 2, so negative 16 plus that 17, that's equal to 1. Log base 4 of 1 should equal log base 4 of 1. Okay, so we are good there. All right, now, log functions, okay, just like we did with the exponential functions, okay, get the exponent by itself, rewrite. With the log functions, get the log by itself and rewrite. Okay, so then if we rewrite, we get 4 squared is equal to that argument of x plus 3. 4 squared is 16. Finally, subtracting that 3 over, and we're going to get 13 is equal to x. Okay, so plugging that in, 13 plus 3, that's 16. Log base 4 of 16 is equal to 2 because 4 squared is 16. So we are good on that equation. Now, I see 2 logs on this one, but it is a little bit different than that previous one. We had log base 4 on both sides where it was equal. Now we have 2 logs on one side of the equation is equal to a value. Okay, so we can't use that strategy we did up above. Okay, so in this case, what we're going to do, since it's log base 2 plus log base 2, we are actually going to condense these logarithms. Okay, so since it was adding, what we're going to do is subtract or multiply those arguments. So x times that x minus 7, and then set that equal to 3. And from there, got that log base 2, simplifying that argument, we get x squared minus 7x. Okay, we got 1 log equal to a value, therefore we're going to rewrite. And we'll get 2 cubed is equal to that x squared minus 7x, or 8 equals x squared minus that 7x. Okay, now we got a quadratic. We got x squared there, so we need to solve a quadratic. Whenever we do that, set it equal to 0. So we got x squared minus 7x minus 8 equals 0. Best method there is going to factor. Now at this point, I don't care how you solve the quadratics. Okay, so you can use a quadratic formula, you can complete the square, whatever method you want to use, go for it. Quickest way in this case is going to be to factor. Okay, it has to be x times x. Signs will be opposite. Okay, multiply to get 8. 1 times 8 is going to work in this case. I need negative 7, so I'm going to make that 8 negative. So x plus 1 equals 0, or x is equal to negative 1. X minus 8 equals 0, or x is equal to 8. Now again, make sure to check your answers. Okay, so when I plug in negative 1, that's going to make that argument negative 1. We cannot have a negative argument, okay? Because if you just break down log base 2 of negative 1, 2 to a power equals negative 1. Okay, we can't take 2 to any power to get it to be negative 1. Okay, the base would have to be negative, which we do not have those types of logarithms ever. The base is always positive. So whenever that argument is negative, that is an extraneous solution, so we have to kick that one out. Okay, so log base 8 then, log base 2 of 8, plus log base 2 of 8 minus 7, which would be 1. Log base 2 of 8, that is 3, plus log base 2 of 1, that is 0. Anytime the argument is 1 is equal to 0. 3 plus 0 does equal 3. So 8 does work. Alright, so those are the different types of situations you will see when solving logarithmic and exponential functions. Homework then. 8.6 homework. Different types of equations to solve there. Don't worry about that number 62. Number 65, you're going to have to set up an equation for that one. Okay. Other than that, if you have questions, make sure to let me know. Otherwise, have a good day.